Hi, Mr. Minnick, helping my students understand PixLab and specifically A5, which involves a bunch of classes, and we're going to focus on the picture class today in this video. Now, they show the College Board folks make this nice little UML diagram, which they never put on the AP exam officially. UML diagrams, they're very useful in college, Unified Modeling Language diagrams. And this shows you the big picture of a bunch of classes and how they're related to each other. So there's this concept of inheritance that's built into object-oriented programming languages like Java, OOP, O-O-P. You can have a class that inherits another class. So in this example, the class picture inherits simple picture. Soon we're going to see that the word extends is what's the key word that's used in Java. So another fact is that picture extends simple picture. I repeat, picture, it inherits simple picture, and you can also equivalently say picture is a child class of simple picture. You could also say picture is a derived class from its base class simple picture. And there is another word that's a synonym, super. You can also say that picture is a subclass of its superclass named simple picture. Now that's all explained in my lecture notes elsewhere. And the bottom line is picture is a child class of simple picture, and let's see what that means when we step through some code here in a few minutes. I will emphasize that the official UML notation is to draw an arrow from the child to the parent with a hollow arrow tip and a solid line. That demonstrates inheritance. It's got to be in that direction if you ever are asked to draw one of these in college. The dotted line up here means that simple picture implements the thing called an interface named a digital picture. Now that's a concept for another video and a whole nother unit of our study, what's called interfaces. Right now we're just going to talk about both of these being classes. Okay, so let's get to it. You'll be reading all of what College Board has in this student guide, but let's go straight to the picture class. The picture class here, you can see at the top of it where its header is, it has that extra optional part, extends simple picture. So that is the actual Java syntax that illustrates this arrow. So what does that really mean? It means that over here in this picture, in the simple picture class, any methods that we have, sorry about this, hold on. Any methods that we have in the simple picture class, I'll just pick one at random, like the method, random method copy picture. The method copy picture can be used by picture objects that are instantiated as picture objects. So when a class extends another class, you get a bunch of extra methods that you can use, I say, for free. Well, we don't see them here, but the methods that they just on this page didn't put in this middle area, all the methods that are here get added to all the methods that are in here that they just didn't bother taking the space and showing in this official UML notation. So basically, if your parent is really good at playing chess and your parent has a play chess method, then without even having the method typed out in your file, you can call .playChess because you get all these methods for free. And guess what? If that class has a parent, in a way kind of like your grandparent, all of those methods in this class over here called maybe graphic. If there's an arrow from here to here, you get all those. If you're down here, if you are the picture object, you have all these methods, and you have all the methods of all the parents above you in the family tree, right up to the top class called object with a capital O. It's the mother of all classes in Java. And that's a lecture or a lesson for another day. Anyway, right here, we just have these two classes to worry about. So in this assignment 5, they want you to scroll down and look at the main method that's part of this picture class and understand why those 4 lines of code work the way they work when we execute this. So I'm going to execute and see what it does, and then we will trace through and walk through these 4 lines of code. So when this executes, first a beach JPEG picture pops up, and right here it is. There's the line 231. The explore method, we saw that in a previous video. The explore method simply brings up a picture that's found somewhere in the folders that the project. Sorry, I'm losing my windows that I need here. So there is the beach scene that's being explored or basically opened up. Then this happens. 0 blue. We're going to be tracing that in about 5 minutes. But finally, beach.explorer executes again, and here is the other picture that ends up coming up because of that line 233. Now this picture is a picture with all the blueness zeroed out. Kind of like a fancy pair of polarized sunglasses. All the RGB, red, green, blue, all the blueness was turned to 0. I'm looking at this student right now with the initials BK, and his hair is a different color than Mr. Ackerman's hair. And I could take all the redness out of his hair, and so basically his hair is like 255, 0, 0. It's all red, and there's no blueness or greenness in it. I could take all that 255 out and make the R part 0. And that would basically change his whole hair color and his personality and everything else. So this is pretty darn interesting stuff. 0 blue, how's it work? Well, let's learn how to step through the code because that's what I'm really teaching here, courtesy of PixLab and College Board. So what kind of object is beach? Because that's where you'll find the 0 blue method typed out. Well, the object variable, beach, was declared as a picture object reference. So we have to go to the picture class, and I know that's a class because it's capital P. Int is not a class because it's a lowercase I. It's a primitive data type built into Java, for example. So where's this picture class? Did it come from the people at Oracle or Java? Well, did we import picture? Nope. Just trust me. None of that is the picture class. Oh, we're in the picture class. My bad. So down here in this main method, beach is this object. We call it the object from the perspective of which I'm executing this code. We call it the THIS this object in this situation. So I don't know if this would execute. Yeah, actually, no, that would not execute. I shouldn't have even shown you that. So anyway, beach.0blue. The 0 blue method is found somewhere in the picture class, which is the class I'm currently in. So let's go find it. 0 blue, 0 blue. Here's a method called edge detection. That's not 0 blue. Okay, I'm just going to create collage. That's not the method I'm looking for. 0 blue, 0 blue. Where's the 0 blue method? It's in here somewhere. I call these interesting methods. There it is. Because it's not a constructor, it's not a set something, and it's not a get something. It's interesting. It's legitimately interesting. Now, the purpose of this method, if it acts as advertised, is to set blue to 0. So in other words, in some JPEG picture, every pixel, which is all pixels, are a combination of some redness, some greenness, and some blueness. So it's taking every pixel, and its blueness is being turned to 0. Still leaving some combination of redness and greenness. But this moves you somewhere on the color palette. Probably to some shade of green, because blue just tends to look like, if the blueness is taken out, it gives you this green overall cast, but not all the time. So let's step through this line of code. Zero blue, or step through these lines of code here. This line of code creates an object variable named pixels. It's a two-dimensional array of pixel objects. So if I had the right creative ability, and if I had a drawing tablet, which I don't right now, I would draw a two-dimensional array here, especially if this were the AP exam. I draw a two-dimensional array with some number of rows and columns to be determined. And inside each like little square here on my two-dimensional array, Tony, right here, where Tony, right there, right here on my screen, where I'm emphasizing that I'd be drawing this on the AP exam. Because one of the strategies for an AP person or anybody in the real world is to know how deep to dig into something technical, but then to know where to stop. We can't possibly, in the code that I'm about to trace through, dig so deep that we're into the everything here. Often my car, when it makes noises, it's something that I can understand, like a fan belt is off or something. Rarely have I had to go to one of the 6 cylinders on my car and actually break that seal and look inside the cylinder to understand why there's some kind of knocking sound from the engine. That's too low level. If it's that bad for a car, I need to buy a new engine. But normally it's something like on the superficial level that I'm handy enough to go to the Pep Boys and buy, and maybe even add to my car myself. So let's see how deeply we have to step through this code before it's too low level that it's another person's job to trace deeper. Okay, so if I were to draw this on my scratch paper here, Tony, I'd have a two-dimensional array of pixel objects. Well, what is a pixel object, you might ask? Don't ask. Okay, you really ask? Let's double click and look at the pixel class. That's a class that they don't really want you to have a deep-rooted knowledge of on the day of the AP exam, but it is interesting for curious minds. It's got all kinds of stuff in it, particularly this method called getBlue, and that we're going to be seeing shortly. Wow. This is like, it's used as one of the bit flicking operators, the single and, not to be confused with the double ampersand, which means and. Oh, it involves hexadecimal number FF. Oh, it's doing the complement. When you and something with all ones, because FF is like 11111111, the value 255, which is all ones in an 8-bit binary number. This is doing something really cool. But you're not supposed to know any of that for the AP exam, so sorry about that. So basically, the pixel class, you're just supposed to understand that it represents a pixel with its redness, greenness, and blueness. Okay, let's go back to where we do have to understand this code that I was just in the picture picture class itself. So we have basically a two-dimensional array that is all of the pixels of that beach.jpg. That's what we have. We have it referenced as rows and columns. We could go to the getPixels2D method, which is in the this class, and it's in the class of the this object. Remember, the this object is currently the perspective from which we are calling zero blue. So this is the same thing as saying beach. And therefore, we know that there is a method called getPixels2D that's also in this same class that we're currently finding zero blue in. I will scroll to find the getPixels2D method. It's in here somewhere. No, it's not. It's not. Oh, because the picture class extends simple picture, the getPixels2D method, that you may or may not be curious to see how it works, is actually in the simple picture class. I double click the simple picture class, which is another one of these classes that the AP people, like Pixel, doesn't really want you to like deep dive down into. This is part of the internal combustion engine that we really shouldn't be looking at, but I'm curious, so I will, a little tiny bit. Somewhere in here, there's a method called getPixels2D. getPixels2D. Somewhere in here. Now, honors Java students, that happen to be in this room, please do a deep dive and look in here, because you're not constrained by the AP exam. You can understand stuff at a lower level than, right here it is, Get Pixels 2D, which basically uses double nested for loop to take the beach JPEG picture and rip it apart pixel by pixel, and to put all those pixels in our nice, easy to work with array of 2D pixels. So basically, it's just giving us a nice way of working with individual pixels. But you don't have to really understand how it works the way it does. So I'm going to go back to my picture class and that zero blue method, which is pretty much all the AP people want you to pay attention to. And they could have used a normal row plus plus traditional for loop here and here, a double nested for loop, but they just wanted to show off, and they are using enhanced for loops, also known as for each loops, to iterate through the whole array of two-dimensional array of pixels. So they're just showing off, and each individual pixel that's being pulled out one at a time into this pretend variable named pixel obj, they're calling the setBlue method on that pixel object. Well, the setBlue method is from the pixel class. That class one of the classes we're not supposed to really know much about. And the setBlue method is basically taking whatever blueness is in any given pixel, a number between 0 and 255, and it's overwriting it with 0 in a way that you are allowed to modify pixel because it's doing it in the right way through the setBlue modifier method. So this is what's basically zeroing out all the blueness, that line of code happening to all 1 or 10,000 pixel objects because of that double nested for loop. Awesome. That's what turns this picture and takes all the blueness out and turned it into that. If I click on any pixel here, the blue, look, the blue is 0 at all those. Whereas here, if I click around the different pixels, every pixel has some amount of blueness between 0 and 255. I mean, there might be some that are zeroness if I looked hard enough, but all those zeros got, all those numbers like 32 got changed to 0. Pretty cool application of real-world color theory in Java code that, with the help of some low-level classes that we weren't supposed to really look at, Pixel and Simple Picture, you could, especially if you're an honor student, have fun with that. Okay, hopefully that helped provide a little bit of insight into tracing the code that's in the main method of the picture class, which, of course, is a child. I lost it on my screen, but remember that it's a child of the Simple Picture class, which is what allowed a lot of those methods to work in the context that they just correctly executed.